The Shapley-Shubik Power Index is what we're studying today, and this is just another way of measuring power in a weighted voting system, which is what we started doing last class. These are a couple of YouTube videos. I'll also put these links up in our Moodle site so that you don't have to type these in exactly. You can link to them through Moodle. But these are really good videos explaining both the Banzhaf Power Index that we did on Tuesday and the Shapley-Shubik Index that we're going to cover today. So they're really like concise and well done. Check them out if you have any confusion still after today. They're a really good resource. All right, so in our last class, we saw the Banzhaf Power Index as a way to measure distribution of power in a weighted voting system. Today, we're going to study another way to measure power in a weighted voting system. There's some vocabulary that you're going to read about in the book, a sequential coalition and a pivotal player. We're going to do an example of another way to measure power using 3 people in the room. So let's have, okay, Ryan, Calix, and Shelby. Come on up. You're not going to have to do any math. Okay, so in the Banzhaf Power Index, these 3 people might have been a team, right? They could team up, all vote the same way, and looking like this, they're a team, right? Now switch order, just change around a little bit. All right. In the Banzhaf Power Index, this is the same team, right? The order that they're standing in doesn't matter. Okay, but in the Shapley-Shubik Power Index, their order matters. Okay, so Shelby, you have 3 votes, Ryan, you have 2, and Calix, you have 1 vote. Okay, so now they go 3, 2, 1, and this is their order that they're standing in. And Shelby says, okay, I'm forming a team. Who wants to be on my team? And Ryan is the next person to join, right? So he joins Shelby with his 2 votes. And now the first and the second players have 5 votes together. And 5 is our quota, right, in this weighted voting system. 5 is the quota. So that makes Ryan the pivotal player in this sequential coalition where the order matters. All right, switch the order a little bit. More than that. Calix, move on. Good. Middle or the front? That's good. Okay, good. Okay, so now Calix is the founder of the team with her 1 vote. And she says, who wants to join my team? And Ryan says, I do. Right, so he's the second player to join the team. And Ryan, you have 2 votes, right? So we have 1 vote for Calix, 2 votes with Ryan. Together they make 3 votes, which is still not enough to meet the quota. That means that when Shelby joins the team as the 3rd member, she's pivotal. Does this make sense? Okay. So the way we're going to measure power in Shapley-Shubik is we have to take every member, every person is going to be on every team. The thing that's different about the teams is the order that they're standing in. Okay, you guys can sit down. So a sequential coalition is a team where the order matters, has every person in the system is on every team, in every coalition, and we just order them differently. And the pivotal player is the player that gives the team enough votes to meet the quota. Okay, so we use just a little bit of a different notation to represent a sequential coalition as opposed to the unordered coalitions from last class. So last class we used the curly brackets, and player 1, player 2, player 3 would have been the same as player 2, player 3, player 1. It's just those 3 players. When we're doing ordered coalitions where order matters, we use like little arrow brackets. And when you have n players, you have n factorial coalitions. Anybody know what factorial means? No, that's not what it means. Calix, you remember what it means? Close, times. Yeah. Yeah. So, yeah. So, for example, with 3 players, the number of coalitions you would have would be 3 factorial, which is 3 times 2 times 1, which is 6. With 4 players, so So for example, 3 factorial is 3 times 2 times 1, 6. 4 factorial is 4 times 3 times 2 times 1, which is 24. So the number of sequential coalitions grows really fast, right? You have a lot of coalitions to compare. 5 factorial will be 5 times 4 times 3 times 2 times 1. 5 times 4 is 20, times 3 is 60, times 2 is 120. So here's a method for finding Shapley-Shubik. The beginning part is different from Banzhaf from last class, but then how we finish is almost exactly the same. Okay, so the beginning part is list all the sequential coalitions. This is analogous to Banzhaf. Banzhaf had us list all the winning coalitions. So this is a little bit different. List every sequential coalition. And every player is on every team. All that changes is we change the orders. B, we find the pivotal player in each sequential coalition. That's the player that when they're added, gives the team enough votes to meet the quota. And then we do the same thing we do for Banzhaf. Count the total of times each player is pivotal and divide by the total number of times all players are pivotal. So this is a slightly different word, pivotal instead of critical, that we used last class. So there is a this procedure and the procedure for finding BPI, the Banzhaf Power Index, are referenced on pages 7 and 8 of this packet, and you can bring them with you to the test. All the reference material that's in this packet you can bring with you to the test. Okay, so you will have everything that you need onto one page. Yeah. So you can use the reference sheet at the beginning of the packet. Page 9 also you can bring, yep. Okay, so let's find the SSPI for this sequential coalition. Sorry, go ahead. No problem. No, no. Yes. Yeah, so if you'll notice, on the first page of your packet is just filled with these. This is for you to use while you're doing your homework, so you don't have to write these out. So there's a whole bunch of them, and actually there's 2 pages of them. So you have a lot of them, and you could photocopy it if you need more than that for practice. And on a test, I would write this all out for you. If there were only 3 players, I would expect you to be able to write it, because then there's just 6 sequential coalitions, which is much more manageable. Let's see where I left off here. There we go. Okay, so we now have this weighted voting system, 5, 4, 2, 1, 1. So the quota is 5, and the players have 4 votes, 2 votes, 1 vote, and 1 vote. So it's 4 players. So we're going to use this table. It'll save us some time. There are several copies of this table on the first page of your packets that you can use in your homework. If I gave you something to do with this on a test and you had to calculate an SSPI for 4 players, I would give you this table. All right, so 5, 4, 2, 1, 1. So my quota is 5, and I'm going to just read each team. So every team has all 4 players on it. The only thing that's different from team to team is the order. So there are 24 different ways we can put those 4 people in order. So the first one is player 1, player 2, player 3, player 4, just the order that they show up in here. So I find it easy if I write each player's votes above them. And you don't have to do this every single time. It's just sort of to help you figure out how to do this. And then you add them from left to right. And as soon as you meet or exceed the quota, the player that you added last is the pivotal player. Okay, so I start with player 1. They have 4 votes. Have I met or exceeded the quota? No. So I go to my next player. I add 2 votes. Now I have 6, and I have surpassed the quota. So that means that player 2 is pivotal. and I just circle them. Maybe I'll underline it. It'll just be a little less messy. Okay, in my next sequential coalition, it also starts with player 1, player 2. So it's going to do 4, 2 again. So player 2 is going to be pivotal in that one. Then in my next sequential coalition, I have player 1, player 3. So player 1 has 4. Player 3 has 1. 2 has 2, and 4 has 1. So add them left to right. 4, not enough. Add 1. I have met the quota. So I underline player 3, second player in the coalition. So the next one's also player 1, player 3. So that's player 3 is going to be pivotal there also. Okay, now I have player 1, player 4, player 2, player 3. So player 1, 4. Player 4 has 1, 2, 2, and 3. So 4, 1. When I add the 1 to the 4, I meet the quota. So player 4 is pivotal, and they'll be pivotal in the next one also. So take a few minutes and discuss in your groups if you need to, and find the pivotal player in each of the remaining 18 sequential coalitions. Okay, so what did you guys get for the pivotal player in every other player 1? Yeah, in every other sequential coalition, player 1 is the player that puts the team over the top to get 5 or more. So these are all player 1s. Player 1, player 1, player 1, player 1, player 1, player 1. Okay, so now we finish calculating the SSPI the same way we do BPI, right? So player 1, right? How many times was player 1 pivotal? 18. Out of the total number of times anyone was pivotal? 24, because there are 24 sequential coalitions. Each coalition has exactly 1 pivotal player. So player 1 has 18 over 24. Player 2, out of 24 times, was pivotal twice. These two right here, yeah. And player 3, same thing, was pivotal twice out of 24. And player 4 was pivotal 2 out of 24 times. So if I reduce the fractions, let's see, 6 goes into both 18 and 24, so that would be 3/4, and 1/12 for everybody else. But again, same as with oh, thank you. Thanks. So same with as with BANZAF, it's helpful to write them in unreduced form, because when you add them all up, what should you get? 24 over 24 for 100% of the power. So 18 and 2 is 20, and 2 is 22, and 2 is 24, so we know we didn't make a mistake. Well, we still might have made a mistake, but that's just an encouraging sign. We didn't make a big mistake. Okay, so now I'm going to have you try to remember last class. Same exact weighted voting system, but I want you to find the BPI, the BANZAF power index that we learned how to do last class. Okay, so let's discuss this one together. How many winning coalitions did you guys find? How many? 7. Okay, so we're gonna have wait. Does any one player have enough votes to pass a motion by themselves? Okay, so we have to start with 2-player teams. Okay, so what 2 players can team up and get 5 votes? So 1 with anybody else can team up and pass a motion. All right, so now we have to look at 3-player teams. Okay. 1, 2, and 3. 1, 3, and 4, and 1, 2, and 4. And the only other three-player team that's possible is 2, 3, and 4, but they don't have enough to meet the quota. So those are my only three-player winning coalitions. And then 4-player, the Grand Coalition, all 4 of them. Okay, so now we have to figure out who is critical. So in the 2-player coalitions, both players are always going to be critical, because if anyone leaves, the one doesn't have enough votes. So critical, 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 oh, critical, critical. Okay. 1, 2, and 3. If 1 leaves, do 2 and 3 have enough to pass a motion? No, so 1 is critical. Now, if player 2 leaves, does player 1 and player 3 have enough? Yeah, because that's 4 and 1, so they have enough. How about if player 3 leaves? 1 and 2, they also have enough. So 1 is the only critical player there. How about in 1, 3, and 4, who's critical? 1. Yeah, if 1 leaves, 3 and 4 just have 2 votes. And if player 3 leaves, player 1 and player 4 still make 5 votes. So 3 is not critical. And if 4 leaves, 1 and 3 still make 5 votes. So 4 is not critical. And then player 1, player 2, player 4, who's critical? Definitely 1, because if 1 leaves, 2 and 4 have only 3 votes together. So now let's check player 2. If player 2 leaves, player 1 and player 4 have 4 votes and 1 vote. They have enough, so player 2 is not critical, and player 4 is not critical. Anybody critical in the 4-player coalition? Player 1. If player 1 leaves, 2, 3, and 4 don't have enough to make the 5 quota. All right, so is anybody else pivotal here? No, I'm sorry, critical. If any of the other 3 leave, the remaining 3 players still have enough to pass the motion. All right, so player 1 to player 4, I'm going to calculate their fraction of the power. We have 2, 4, 6, 8, 10 total times anyone is critical. Is that why you said 10, Shelby? Yeah. Okay, how many times out of those 10 is player 1 critical? 7. Player 2, 1. Player 3, and player 4, 1. So player 1 has 7/10 of the power. Everybody else has 1/10 of the power. Quickly add them up. Yep, you 7, 8, 9, 10. You get 10 out of 10. So we did it right. Yeah. All right, so we now have 2 ways of measuring power. Banzhaf Power Index, or BPI for short, and the Shapley-Shubik Power Index, which is, we say SSPI for short. Shapley-Shubik, again, are 2 mathematicians who invented the method. All right, so suppose there's a king. Oh, question, yeah. Uh-huh. They call them, oh, a beta, yeah, the Greek letter beta, yeah. You don't need to know that. I mean, that's just notation that the textbook uses. I think that the notation actually confuses what's happening. Like, I'd rather just not ignore it and do the method. Okay. Oh, and that number 3 that you asked me about in 1-6, I'm still trying to figure out how to take it out of the homework. So if you got it wrong, don't worry about it. I'm going to fix it later. Yeah. Oh. Oh, really? Oh, okay. All right. Might be a glitch in the like number generator or something. Yeah. Okay, so let's suppose there's a king. He has 4 advisors, and he can be overruled if all 4 of his advisors disagree with his ruling. What voting system is this equivalent to? So try to come up with a voting system using this method. there's going to be the king plus 4 advisors. 1, 2, 3, 4, 5. Assign votes to each of the voters, the king and his 4 advisors, and a quota, so that this is true, so that he can be overruled if all 4 of his advisors disagree with him. All right, what did you guys come up with? 4 is the quota, and then what? Oh, okay. 2, 1, 1, 1, 1. So let's think about if the 4 advisors team up, they have 4 the quota, right? And then the king, so that's the only way they can do something other than what the king wants, is if all 4 of them do something different. So that's good. And then so the king has 2, and to get the 4, he needs 2 advisors to agree with him. Good. Anybody have something different? 5, 3, and then all 2s. Okay. So that works because, oh no, because I think that any 3 of the 2s could team up and overrule the king. And we're supposed to have the only way to overrule the king is if all 4 of them team up. Right? So set the quota to 8. Okay. Yeah, that'll work. Then that's the only way to do something different than what the king wants. The king is in every other winning coalition, in other words. Yeah, Calyx. Okay, so we could have 3 in that spot also. That's good. That gives the king a little more power because he only needs 1 advisor to agree with him to do anything. Good. So there are 5 voters in this system, and there were 24 sequential coalitions for 4 voters. And we calculated it a few pages ago that there would be 120 sequential coalitions with 5 voters. So spend the rest of the class. No, I'm just kidding. Calculating BPI and SSPI becomes very time consuming as the number of players increases. So by hand, I would only ever ask you to do 3 or 4 players. But we can use technology to help us do some of the hard stuff, some of the tedious stuff when we have too many players to do this all out by hand. So we already calculated the SSPI for 5, 4, 2, 1, 1. It was this one. This is the 5, 4, 2, 1, 1. Yeah. So it's 3/4, a 12th, a 12th, a 12th. So I'm just going to confirm that using this neat little tool that's online. All right, here we go. Just taking a moment to load. Yeah, I accept. Run. All right, so now I want to, now that I have confirmed my 5, 4, 2, 1, 1 thing that I already calculated by hand, now we're going to find the SSPI for the king example, because there were 5 players. So we'll just use one of the ones that we came up with. So I have to add a row because there are 5 players now. Oops. Yep. Oh, am I? Okay, thanks. Shapley Shubik. There we go. All right, so now I got to change these weights. Okay, the weight for the king, we'll do the 3, 1, 1, 1 thing. 1, 1, 1, 1. So we gave the king 3 votes. All of his advisors each have 1, and then we're going to put the quota at 4 and compute. And our power distribution is 60%, 10%, 10%, 10%, 10%. So this is your final power distribution. These are the unreduced fractions, and the denominators are all 120 because there were 120 sequential coalitions. Yeah. Yeah, it's pretty neat. And we could switch over to Banzaf, and we get similar results, but not quite exactly the same. Because Banzaf and Shapley-Schuberg are different methods, so they measure power a little differently. All right, so part of tonight's homework, I just want to point out quickly, it's written in the other things to do section, asks you to go to page 3 of this document, the third page of your packet, and cut out the long rectangle and the short rectangle. So let's go up there and see what that is. 40. So I want you to cut out this long rectangle of the alphabet, 2 copies of the alphabet. Page 3, yeah. This was 35. The long rectangle and the short rectangle, which contains letters A through Z. So you want to cut out both of those things. There's 3 copies of the alphabet, basically. So there's 2 copies right next to each other. Cut that out as 1 rectangle, and then cut out this single copy of the alphabet as well. So you're going to have 2 little strips of paper with you on Tuesday in class. It's going to help us with the cryptography stuff to have those cut out and easily visible. Okay, so remember the Frontier High School problem we were working on last class? We were calculating the Banzaf power index for the 3 towns. So today, as part of your class activity, I want you to calculate the Shapley-Schuberg power index for the 4 towns. And I wrote out all the sequential coalitions for you. And then in addition to that, there's another problem where I want you to calculate both the BPI and the SSPI, so you can practice both of them.